In this video, we're going to take a look at the model of the decline of bluefin tuna. So this problem I got from the PowerPoint presentation. So let me go there and read that problem to you. So we are modeling the decline of bluefin tuna, which are large fish that can weigh 1,500 pounds and swim at speeds of 55 miles per hour. Because they are used for sushi, a prime fish can be worth over $50,000. That's just one fish. As a result, the Western Atlantic bluefin tuna have had their numbers decline exponentially because they're so valuable. So everybody's trying to catch them. So their numbers in thousands from 1974 to 1991 can be modeled by the formula f of x equals 230 times 0.881 to the power of x. Notice that this is an exponential function, and that's because the variable is in the exponent. And this is a declining or decreasing function because notice that the base is less than 1. You have exponential growth when your base is greater than 1, and you have exponential decline when it's less than 1, or I should say between 0 and 1. X is the number of years after 1974. So in the next slide, we are asked to estimate the number of bluefin tuna in 1974 and in 1991. Now, since X is the number of years after 1974, we're just going to X equals 0 for the first number. And then X equals, let's see here, 17 for 1991. So let's go to the calculator. And go ahead and do that calculation. Okay, so our formula is f of x equals 230 times 0.881 to the power of x. Remember, the first x that we're going to calculate is when x is 0, because we want to do 1974, and x is the number of years after 1974, so x would be 0 in this case. When x is 0, 0.881 is going to be 1, so the result is 230, and that's the numbers in thousands. So I didn't need to use the calculator for that one. So if x equals 0, then we have f of 0 is 230 times 0.881 to the power of 0. Anything to the power of 0 is 1, so we just get 230, and that's in thousands. Okay, so the answer is 230,000, and that would be in 1974. That's the population. Okay, now in 1991, x is going to be 17. So when x equals 17, we have 230 times 0.881 to the power of 17. And now I'm definitely going to need my calculator to do this. So let me share my screen. So we have 230 times 0.881 to the power of 17. And this is in thousands. So you can see the decline has gone from 230 down to just 27, if you round it, 1,000. And that's quite a decline. So that was in 1991. So we have, let's see, 26 points, let's just say 26.7, which is 26,700. I found a better marker, which is good. All right, so here we have So in 17 years, it's gone down over 200,000. That's quite a bit. Now, let's go back to the problem that we were looking at. The next part is to determine symbolically the year when they number 50,000. So they've gone down to 26, from 230 to 26 something. So we know that it's going to be somewhere in between 1974 and 91. And so we're going to, this time now, we're given the number and we need to find the year. So that we need to find X. So this time 50 is our function value, and that's equal to 230 times 0.881 to the power of X. And to get that X out of the exponent, we want to go ahead and isolate this term right here. We want to get this by itself. So I'm going to divide both sides by 230 to get this out, 230 out of the way. And as always, I like to put my X on the left-hand side, so I'm going to go ahead and take this 0.881X on the left and bring my 50 over 230 on the right. And now to get that X out of the exponent, I'm going to take the natural log of both sides. You can do the common log if you want, but I always like to do the natural log. It's just shorter, less writing. And so now we can bring that X out front because of the properties of logarithms. So X times the natural log of 0.881 is equal to the natural log of 50 over 230. Okay. And now at this point, I'm going to get X by itself. So I'm going to divide both sides by the natural log of 0.881. As long as we do it to both sides, we keep our equality. So now I have that X is equal to, I'm going to go, X is equal to this right here. So I'm going to go ahead and calculate that with my calculator. Let's see here. Okay. So I take the natural log of 50 over 230. Don't forget to close your parentheses when you do this. And then you're going to divide by the natural log of 0.881. And so it's about 12 years later, after 1974, is what we get. So the year then would be 1986, would be the year that the population was 50,000.